Hello to everyone. In this video, let us discuss alkaline earth metals. So, what are the general properties and anomalous nature of beryllium, etc. topics here. So, let us see what are alkaline earth metals here. In periodic table, second A group elements are called alkaline earth metals. What are those elements here? Beryllium, magnesium, calcium, strontium, barium, and radium. What are atomic numbers here? Beryllium 4, magnesium 12, calcium 20, strontium 38, barium 56, radium 88. These are the atomic numbers of these second A group elements. And why these are named as alkaline earth metals? See here, except, that means beryllium, except beryllium, hydroxides of remaining these second A group elements having basic nature and thermally stable. They do not decompose even on strong heating also. So the compounds which do not decompose even on strong heating, those are called earths. EARTH, earths. So these elements are called as which one? Earths. And also these are having which one? Metallic nature. And all these hydroxides except beryllium remaining are purely basic nature. So these are called as which one? Alkaline earth metals. Okay, among these alkaline earth metals, beryllium is the rare element and radium is the rarest element. They are not available in much abundance. Very less abundance is there availability very less. Okay, now next one here, calcium is the fifth most abundant element and magnesium is the sixth most abundant element in the earth's crust. And of course strontium and barium are less abundant. Okay, this is regarding which one here? Name and abundance of these second A group elements. Now let us see some properties here. General electronic configuration of these elements is which one? Means ns2. Okay, now let us see atomic size, and also we can call it as atomic radius. So what about this atomic size means? We know that from top to bottom, that means from beryllium to barium, leave the radium because that is radioactive element. So our discussion is confined up to barium only. So now atomic size increases from beryllium to barium, but these elements are having less atomic size comparatively with corresponding first A group elements. That means comparatively lithium, beryllium is having smaller atomic size. Comparatively sodium, magnesium is having less atomic size. So like that, these are having smaller atomic size comparatively with which one? Corresponding first A group elements. But top to bottom atomic size increases. So this is regarding which one here? Atomic size. Next come to ionization potential or ionization enthalpy. Now let us consider these in three different points, and the different types we have to explain this. What happens from top to bottom is first one, and comparatively with alkali metals is second one, and in that second IP first IP comparison is the third one. So like the three parts we have to learn ionization potential. From top to bottom, ionization potential decreases. Top to bottom, what happens here? Ionization potential decreases because size increases, nuclear attraction on outer electron decreases. So as usual IP decreases. And here if you compare the second IP and first IP of these elements, IP2 is almost double to the first ionization potential. Highest second IP here. Second IP is almost double to the first ionization potential. And comparatively with the first A group elements, if we compare this one here, IE1 of second A group elements greater than that of first A group elements. But IE2 of second A group elements less than that of first A group, because after losing one electron, first A group elements get into inert gas configuration. So that's why removal of second electron from first A group elements is much and more difficult comparatively second A group elements. So for this reason, second ionization potential of second A group is less than that of which one, first A group elements. So this is regarding which one here, ionization potential of these second A group elements. Okay, then after ionization potential, let us see which one here means that hydration enthalpy. So what is hydration enthalpy? The heat energy liberated when any substance dissolved in water, that is known as hydration enthalpy. And we know that as the size of that substance decreases, DE decreases, what happens? Heat of hydration increases. So now here, if you compare first A group and second A group elements, in a period from left to right, atomic size decreases. That means second A group elements having smaller atomic size comparatively with corresponding alkali metal. That means here beryllium atomic size is smaller than that of lithium, and magnesium atomic size is smaller than that of sodium. So that's why here, comparatively with the first A group elements, the corresponding second A group elements having high heat of hydration value is observed for which one, second A group elements. And of course, in that what happens here, from beryllium to that barium, as atomic size increases, that heat of hydration decreases. So beryllium plus 2 greater than Mg plus 2 greater than Ca plus 2 greater than Sr plus 2 greater than Ba plus 2. So like this here, these elements shows which one, high heat of hydration. And already we discussed here, comparatively first A group elements, these are having high hydration enthalpy and high hydration capacity also. So now here, if you come to which one, MgCl2, that exists as 8H2O, CaCl2 exists as CaCl2 6H2O. Like this they can form which one, hydrates. Of course we know that sodium chloride and potassium chloride does not form such type of hydrates. So these are having which one, high affinity to bind with which one, water. That's why these are having high heat of hydration. And one more thing here, even second IP is much greater than first IP, double, almost double to say that first IP. All these elements exist in M plus 2 state. They do not exist in M plus 1 state. Why? Because this heat of hydration dominate over second ionization potential. So due to the domination of heat of hydration of these alkaline earth metals over second ionization potential of them, they can exist in which state means plus 2 oxidation state. Okay, this is regarding which one here, that heat of hydration. And let us see oxidation state. All these elements exhibit +2 oxidation state. Just now we discussed that due to high heat of hydration, and that heat of hydration dominate over second ionization potential. So they exist in which oxidation state here? +2 oxidation state. Okay, now let us see which one here, reducing nature. Already in first year group elements video, we learnt what is this reducing nature. Now, all these second year group elements act as reducing agents because by losing electrons, they tend to get into inert gas configuration. Like that, by losing electrons, they themselves undergo oxidation but act as reducing agents. Now, comparatively with alkali metals, of course, these are having less reducing capacity because as atomic size decreases, the tendency to lose electron also decreases. So like that here, comparatively with the corresponding first year group elements, these are having less reducing tendency. But in overall, these are also having which one, high reducing tendency, and by losing electrons they act as which one, strong reducing agents. And that is what is evidence for that, means these are having more negative that reduction potential value. So due to the presence of more negative E naught value, that is the evidence for that which one, reducing capacity of alkaline earth metals. Okay, this is regarding which one here, reducing nature. And which is having highest reducing power means beryllium, that is having highest reducing power in alkaline earth metals. Okay, this is regarding which one, that reducing nature. Okay, now let us see another one here, that is flame coloration, or they exhibit which one, flame colors. That means when alkaline earth metals are ignited to a flame, they impart different colors. Of course, here beryllium and magnesium, due to smaller atomic size and high ionization potential, they do not exhibit the different colors. They do not exhibit the colors. Now, the remaining elements, that means here calcium, and here you can write strontium, barium, and radium, exhibit the colors. Calcium will give which color, means brick red color. This is easy to remember. Calcium means immediately we have to remind which one, that whitewash. For which we use whitewash means for which one here, for the walls, and walls are constructed with which one, bricks. So immediately have to remember that brick. So calcium is having brick red color. Strontium means just to remember this color, make a small change. Instead of S, write C. CR means that is nothing but crimson red color. And ba means how to remember that, of course barium. How to remember that means like ball, ball. In our fruits, which is in the shape of a ball, means apple. So now remember this color as apple green color, that exhibit apple green color. And r, radium, in that r is there, so write red, red, but not normal red, caramine red color. So these are the colors of which one, second A group elements. And let us see first A group elements colors also, then only you can easily remember. Now lithium is having crimson red color, and sodium is having golden yellow color, golden yellow color. And potassium is having lilac color, potassium is having lilac color. Okay, then rubidium is having red violet color, red violet color. And cesium is having blue violet color. So these are the colors of which one? Alkali metals and alkaline earth metals. This is regarding which one? Flame coloration. Okay, these are the some general properties of which one means here alkaline earth metals. And of course, in alkaline earth metals, the first element, nothing but beryllium, shows some anomalous properties. So now let us see anomalous behavior. Anomalous behavior of beryllium. What is its anomalous properties? Anomalous properties of beryllium. So let us see that. First one is here, due to smaller atomic size, beryllium predominantly give which compounds means covalent compounds. Beryllium predominantly form covalent compounds, and beryllium is amphoteric in nature. Amphoteric in nature, and it reacts with alkalis. Beryllium reacts with alkalis and form berylates associated with evolution of hydrogen gas. But remaining alkaline earth metals do not react with alkalis. Okay, then oxides and hydroxides of beryllium are having which one? Amphoteric nature. But remaining alkaline earth metals, oxides and hydroxides are having basic nature only. But beryllium oxides and hydroxides are having amphoteric nature. They react with both acid and also bases. Okay, then another one here, another anomalous property here, beryllium covard, that means coordination number is 4, that does not exceed the 4, because it has only two orbitals in that outer shell. But remaining elements, in case of remaining elements, that coordination number is how much means 6, but beryllium coordination number maximum how much means here 4 only. So due to the presence of vacant d orbitals, other elements, that coordination number is reaches how much here 6. And another one here, beryllium, due to smaller atomic size, it forms which one? Complex compounds. But remaining alkaline earth metals does not form such type of complex compounds. So these are the anomalous properties of which one? That beryllium. Okay, then beryllium shows diagonal relationship with which one? Aluminium. So now let us see diagonal relationship, diagonal relationship of beryllium with aluminium. So due to that same polarizing power and due to almost same atomic size, they can have which one here? That diagonal relationship. Now what are the similar properties? Let us see here. Both beryllium and aluminium does not attack by which one? Acids. Does not attack by acids. Due to the presence of protective oxide layer, both of them are not attacked by acids. Okay, then both oxides and hydroxides, both hydroxides are having amphoteric nature. Both hydroxides having amphoteric nature. Beryllium hydroxide dissolves in alkalis to form berylate with formula BeOH taken for -2. And similarly aluminium form aluminates AlH4 AlOH taken for here -1. So like that here, similar to aluminum, beryllium also form which one compounds by reacting with the bases. And another one here, halides of both halides are exist as which one here, bridge dimers. Halides of beryllium and aluminum now exist as which one here, bridge dimers, and they act as strong Lewis acids. That is also another similarity. And another one here, halides of these two act as catalysts in which one, Friedel Crafts reactions. In Friedel Crafts reaction, halides of these beryllium and aluminum acts as which one means catalysts. And another one here, both beryllium and aluminum form complexes. So see here, AlF6 minus 3. Both can form which one means complex compounds. And both these having electronegativity value 1.5. So these are the similarities of which one, that means beryllium and aluminum. So this is regarding which one here, general properties. General properties of which one, that that second A group elements. Okay, bye.